In our view, concepts appear as a milestone in the design process. Usually, at least 3 concepts are developed, each with their own pros and cons. Before spending a lot of money and time in the next phases of design, a designer wants to discuss these concepts with users and other important stakeholders. With one concept only, there would be nothing to choose and not much to discuss. So before rushing into the next phase, you would like to evaluate how well the concepts solve the earlier identified design problem and to what extent they fulfill the design challenge. You also want to know whether the product seems producible, meaningful to the user, appropriate for use, and whether most requirements are met. Our definition of design concept is therefore a representation in drawings and text of the design solution that has enough detail to allow you to judge the main functioning of the product, as well as its use, aesthetics, production, and commercial possibilities. A design concept should be a realistic solution, but does not have to be validated yet. A design concept remains a realistic dream on paper. Sometimes a design concept is defined as a general idea, something formed in mind. In a way, this is correct, but we would consider this definition as a starting point for developing the concept. So concepts are preceded by idea generation and idea selection. My students often ask me to what extent they should detail their concept, and my answer is always up to the moment you have no time left to continue. In practice, because of this time restriction, we see the to-the-point concise concept as well as fully detailed concept which come close to the preliminary design. Each concept has its own starting point. For example, one concept based on the philosophy of maximum sustainability, another on cost efficient, or the third concept of optimal comfort. Or as shown in this slide, different concepts for the assembly of cooling modules in the kitchen. Actually, it is your choice what view on the design problem you wish to use and to what extent your concept should be detailed. More important is that all concepts that you want to evaluate and decide between are equally detailed. You can understand that it would not be fair to compare a fully detailed concept with concepts that are only roughly detailed. It's like comparing chalk and cheese. The next issue is how you should develop different concepts. Many methods are available to analyze problems, involve users, generate ideas, and evaluate and select. However, for developing concepts, the diversity in methods is rather poor. You can work outside in or inside out. When you work outside in, you can start with defining the appearance or interaction of the product. Or in case of inside out, you can start with the configuration of the components inside. In both ways, we work concentric and in many cycles. This is also the case when working on a separate studies, such as a form study, an ergonomic study, or some simple calculations on mechanical issues. All this is done by making drawings. Making drawings is an approach that takes the idea out of the mind to the drawing board in order to actually judge the result and trying to improve or adapt by imaging again. This too is a loop: imaging, presenting, and testing. In fact, drawings are simulations of what is in the mind, but so are tests, models made out of foam, cardboard, or wood, like this mechanical model of an ice crusher. Some consider the development of concept as the process of divide, solve, and reconnect, since most designers tend to do this and divide the development in problem areas or parameters, analyze them, and find different possibilities or solutions. The reconnect part of this process results in an ideal combination of sub-solutions, forming the complete product. For each sub-problem, the designer will work cyclic and concentric, going through analysis, simulation, evaluation, and decision-making. This basic design cycle is repeatedly done and is called iteration. Usually, the reconnect part of concept development results in some sort of balance. Dimensions of some purchase part might not allow the preferred shape of the housing, or comfortable maintenance might cause high assembly costs during production. Designers often have to agree to less perfect solutions to make things fit and comply to all requirements. It is hard to design a perfect product with the perfect aesthetic value, the longest life, the ideal recyclability, the most comfortable use, the cheapest in price, and so on. So all parameters will have to be balanced out. The last part of this lecture is about presenting your concept. You have already seen some concept presentations with drawings and some text. Drawings can be handmade or with specific software on your computer. Be sure main dimensions are mentioned and keep them in proportion. During idea sketching, this is less important, but for the concept, you really have to pay attention to this. Be sure that, for example, 50 millimeters is half the distance of 100 millimeters. If not, you will be fooling yourself. Use at least 2 side view drawings on each concept. Sometimes a cross-section or a sketch in perspective explains more and better. Putting a human figure or well-known object in the drawing helps to indicate the size of your product. Describe the use of the product, perhaps with a scenario. Use text to describe your vision, clarify the concept or explain your drawings, but keep it to a minimum. Above all, keep the style and the level of detail the same for each concept. Thank you, and please do try this at home.